Welcome to the deep dive. Today, we're diving into something that I think you're going to find really interesting. We're looking at how AI is being used to diagnose breast cancer.
It's a really hot topic right now.
Yeah, we've got this whole stack of research articles here, and they're all about these things called CNNs.
ZNNs.
Yeah, convolutional neural networks, but everyone just calls them CNNs. It's
Yeah.
way easier.
Makes sense?
So they're like the hottest thing in AI image analysis right now. And get this, it's not just about mammograms anymore. These articles cover 5 different imaging methods.
5?
Yeah, mammograms, ultrasounds, MRIs, CT scans, and even histopathology.
Histopathology, you mean?
Yeah, where they look at actual tissue samples under a microscope.
Wow, that's impressive.
So get ready, because we're going to figure out how accurate each method is with AI. What the good and bad points are for each, and what it all means for the future. What's coming down the pipeline for diagnosing breast cancer.
It's a
Yeah.
fast-moving field for sure. What's exciting is that AI could really make diagnosis more accurate and consistent. Because think about it, even the best radiologists, pathologists, they can sometimes see things differently. It's really hard.
Totally. So AI is like another set of eyes, right?
Yeah, and they're powered by, algorithms and tons of data.
Okay, so we've got all these different ways to look for the same thing. Mammograms, ultrasounds, MRIs, the whole shebang. Why so many? I mean, why not just one perfect method?
Well, each one has, its own strengths and weaknesses. Like take mammograms, they're really good for catching things early. But sometimes you get those false positives,
Oh, yeah.
especially for women who have dense breast tissue.
Right, and that can be stressful, leading to, more tests that maybe weren't even needed.
Exactly.
And what about ultrasounds? I know they use them a lot for breast exams, but the images always look kind of fuzzy to me.
Yeah, you're right. They are fuzzier, but they are easier to get and cheaper than an MRI. The downside is they might miss those really tiny details that could be a sign of trouble. MRIs give you a super detailed picture, but they're expensive and not really practical for routine screenings.
So each method's got its pluses and minuses. It's like a trade-off.
Yeah, exactly.
So where does AI fit into all of this?
That's where it gets really cool. AI is being used to overcome those downsides and make diagnoses more accurate no matter which method you use. It's all about helping doctors make the best choices, not trying to replace them.
Gotcha. So it's more like AI is the sidekick.
Yeah, I like that analogy.
But before we get into all the nitty-gritty of each method,
Yeah.
can we do a super quick AI 101? We keep hearing about these CNNs. What are they? How do they actually work?
Okay, so imagine a network of artificial neurons, sort of like a simple version of our brains. Now, picture those neurons organized in layers, and each layer is looking for specific stuff in an image, features. The first layer might learn to see simple edges, textures. The next layer up might start picking out shapes. And by the time the image gets to that last layer, the CNN, it's built up this really deep understanding of the image.
Whoa, that's wild. So it's not just looking for a specific thing. It's more about understanding the whole image.
You got it. And the cool thing is, CNNs learn by doing. So we feed them tons of data, like images of breast tissue, and they just keep getting better at spotting those little differences, the things that make a tumor different from healthy tissue.
Okay, that makes sense. So it's like training a detective to spot a fake, like a counterfeit bill.
Exactly. The more they see, the better they get. Of course, it's not as simple as just showing a bunch of pictures. There's a lot of training involved, making sure the data is labeled correctly, the AI is learning the right stuff.
Makes sense.
But the potential is huge, especially in medicine, where things are super complex and we don't always have a lot of data to work with.
Okay, so CNNs are like super pattern spotters that learn as they go.
Got it. Now, you said earlier that histopathology is the gold standard, looking at the actual tissue. Why is that? And do we even need AI for that? I mean, you look at the cells, you see if it's cancer.
Yeah, you'd think so, right? But even the most experienced pathologists can interpret things a bit differently.
Really?
Yeah, studies have shown that there can be disagreement between pathologists, even when they're looking at the same samples.
Wow, I didn't know that.
And even a tiny error can have a huge impact on a patient's life.
No kidding.
That's why AI is making waves in histopathology. Some studies are showing that AI can be 99% accurate at finding cancer cells.
99%.
That kind of accuracy could help make diagnoses more consistent and, potentially catch more cancers early on.
So how do they even use AI for something so, delicate? Do they just scan the slides with a fancy machine?
It's actually more sophisticated than that. They use some pre-processing tricks to make the images better before the CNN even sees them?
Tricks, like what? Well, for example, there's this thing called stain normalization.
Stain normalization.
Yeah, so the dyes they use to see the cells under the microscope, those can vary a lot between labs. That can make it harder for the AI to learn. So stain normalization evens out those differences, and the AI gets a much cleaner image to work with.
Ah, okay. So it's like making sure all the pictures the AI is learning from are printed on the same kind of paper.
Exactly.
Yeah.
And they also use a technique called creating image patches. They basically break down the big microscope image into smaller chunks that the CNN can analyze more effectively. It's about making the data AI friendly.
So it's not just about the AI itself, it's about prepping the data for it.
Right.
Right.
Give it the best chance to succeed. Okay, ready to move on to something a little more familiar?
Yeah, sure. Let's talk about mammograms. I mean, everyone's heard of those, but where does AI fit in?
AI is already making a big difference, especially when it comes to early detection.
Right, which is so important.
Absolutely. We've seen studies where AI is helping radiologists read those mammograms more accurately. In fact, one study reached 96.52% accuracy.
Wait, 96%? That's
It
amazing.
is, especially when it comes to finding those tricky early-stage cancers that are easy to miss.
But you mentioned earlier that mammograms have their own challenges, like image quality and different breast densities. How does AI deal with that?
They're using some pretty innovative techniques. One approach is to actually use AI to improve the image quality before it even gets analyzed.
Really? How do they do that?
They use this technique called CLAE.
CLAE.
Yeah, it stands for Contrast Limited Adaptive Histogram Equalization. It's kind of like those photo filters that make everything brighter and sharper, but specifically designed for medical images.
That's pretty cool. So it's like the AI is getting a pre-screening before it even starts its main job.
Yeah, exactly. So AI is not just helping to read mammograms, it's helping to make the mammograms better.
Okay, so we've talked mammograms and histopathology. What about those more specialized scans like MRIs? Aren't they already super detailed? What can AI add to that?
It's not just about seeing if a tumor is there. MRIs give you a lot of info, and AI helps unlock even more. For example, AI can predict not only if there's a tumor, but also what kind of tumor it is.
Wait, what? So it's getting specific.
Yeah, and that's important because different types of breast cancer respond differently to treatments.
Oh, I see. So knowing of the type helps the doctors pick the right treatment.
You got it. It's about personalizing treatment, tailoring it to the individual patient.
Wow. And I'm seeing here that one study using like a multi-layer CNN thing got nearly 98% accuracy in classifying those tumor types just from the MRI images.
It's amazing, right? And what's even cooler is that in that same study, they used AI to actually reduce noise in the MRI images. They're basically using AI to sharpen the tools themselves.
So AI is like this all-around assistant. Okay, we've done mammograms, MRIs, even histopathology. But what about ultrasounds? I know they use those a lot, but the images, they always look kind of fuzzy to me. Can AI even work with that?
You might be surprised, AI is doing incredibly well with ultrasounds. Some studies are showing close to 99% accuracy, even with those, less than perfect images.
Wait, really? 99%? I'm shocked. That means ultrasounds, which are cheaper and easier to get than MRIs, could be way more useful for finding cancers early.
Exactly.
So how are they getting those amazing results when the images aren't great?
One study we've got here used this two-stage grading system called BIR-AIDS. It's already used by radiologists to categorize breast abnormalities, so it's like a language they already speak.
So they're teaching the AI to speak doctor, basically.
Smart. Yeah, it helps to smooth the transition into using AI in actual practice.
Okay, so these accuracy rates are incredible, like across the board.
They really are. It looks like AI has the potential to totally change how we diagnose breast cancer, making it more accurate, efficient, and accessible for everyone.
That's a really great goal. Okay, last but not least, let's talk CT scans. I thought they mostly use those for like lung or bone issues. Are they even used for breast cancer?
You're right, they aren't the first choice, usually. But there's more and more research being done, and AI is playing a big role in that. Researchers are using it to analyze PT-CT scans.
PT-CT scans, what are those?
It's basically a combination scan. It can actually show how active a tumor is.
Interesting. So it's not just about finding the tumor, it's like understanding what it's doing.
Exactly.
So it sounds like AI is showing some promising results with CT scans. One study here mentions getting 96% sensitivity using a CNN called exception.
It's one of the many types of CNN architectures.
But what does sensitivity actually mean in this context?
Sensitivity is how good the AI is at correctly identifying actual tumors. In other words, it's about how likely the AI is to catch a real tumor, not miss it.
So it's all about minimizing those false negatives,
Right. Cases where a tumor's there, but it's missed.
which is, super important for catching cancer early.
Exactly. Early detection is key.
Yeah.
And AI is proving to be a powerful tool for that.
Okay, wow. That was a whirlwind tour of AI and breast cancer diagnosis. I mean, we've seen some really impressive numbers here, from 99% accuracy with histopathology to almost 98% accuracy with classifying tumor types from MRIs. But what does this all mean for, like, the average person? What's the takeaway here?
I think the most exciting part is that AI could make breast cancer diagnosis more accurate and personalized for everyone. It's not about replacing doctors. It's about giving them more information to make better decisions.
So it's not AI versus doctors. It's like AI and doctors working together. I like that. It's a team effort.
Yeah.
But it seems like we're still kind of in the early stages of all of this, right? What's next? What are researchers working on that's got you really pumped up?
One of the big things is combining information from all the different imaging types. So instead of just looking at a mammogram or an ultrasound, you could look at both. Maybe even throw in an MRI or CT scan to get the full picture.
Right. Yeah, that makes sense. It's like getting multiple opinions, but from like different imaging techniques, not different doctors. But how does that actually work? Would doctors have to look at each image separately?
That's where AI steps in again. It can help us put those different pieces together, create a more complete picture.
It's like putting a puzzle together, right? But instead of a flat image, it's like you're building a 3D model of the tumor. You see it from all sides.
Exactly.
Yeah.
And AI is the key to unlocking that multidimensional view. It can help us pull all that data together and understand the tumor in a much deeper way, like its size, its location, all the details, and even how it's behaving.
So instead of just one snapshot from one type of scan, you're getting this whole like interactive model.
Yeah, pretty much.
That's amazing. But it also sounds super complicated. Would doctors even be able to make sense of all that information?
Well, that's the beauty of AI. You can go through huge amounts of data and spot patterns that, we humans might miss. It can point out things to watch out for, highlight any changes, even predict how the tumor might act in the future.
Wow, that's like having a crystal ball, but for cancer. Okay, but we've talked a lot about diagnosis. What about treatment? Can this multimodal analysis help make treatment plans more personalized too?
Definitely. We're talking about combining info from all the different scans, plus genetic data, lifestyle stuff, even patient preferences, to create a treatment plan that's truly individualized.
So it's not just one size fits all.
Nope.
Yeah.
Imagine being able to say, okay, for this patient with this type of tumor, these therapies are most likely to work.
That's incredible. It's like having a personalized map, guiding you toward recovery. But with all this potential, there's got to be some challenges, right? What are the roadblocks here?
One of the biggest is data access. You see, these AI algorithms, they need a ton of data to learn. And in healthcare, well, that data is often spread out all over the place. Different hospitals, different systems. It's not easy to get it all in one place, especially while keeping everything secure and protecting patient privacy.
Yeah, privacy is huge. So it's not just about building the tech, it's about building the infrastructure to support it.
Exactly.
Yeah.
But there's another piece too, the human side of things. We have to make sure that both doctors and patients are comfortable using these AI tools. Doctors need training on how to understand the results, how to talk about them with their patients, and how to use them to make the best decisions.
It's like you can give someone a fancy new gadget, but it's useless if they don't know how to use it.
Exactly. And patients need to understand how this all works too. The potential benefits, the risks, how it might change their care.
It's all about feeling empowered, right? Whether you're the doctor or the patient. Okay, so we've talked a lot about AI and breast cancer, from the technical stuff to the really big possibilities. What are your final thoughts, like the big takeaway message?
For me, it's about approaching AI with a balance of excitement and, well, caution.
Hmm.
AI could completely change healthcare in ways we can't even imagine yet, finding cancers earlier, personalizing treatments, even saving lives. But we have to be aware of the risks, make sure we're using it ethically and responsibly for the benefit of all patients.
That's a really good point. It's not about blindly trusting the tech. It's about using it thoughtfully and carefully.
Right. Remembering that technology is a tool,
Mm-hmm.
and it can be used in different ways. It's up to us to decide how we use it.
Absolutely. So to everyone listening, stay curious, stay informed, and stay involved in this conversation. The future of healthcare is being shaped right now, and your voice matters. We'll be back in a moment to wrap things up and leave you with some final thoughts to ponder.
Welcome back to the deep dive.
So I gotta say, my mind is kind of blown by all the possibilities here. Like AI and breast cancer diagnosis, who knew it was this advanced?
Right. It's really incredible how far things have come.
We've talked about everything from how these AI algorithms work, the whole CNN thing, to all the different ways they're being used with these different imaging methods.
And we even touched on how AI could personalize treatment. That's a big one.
Yeah, it is. It's like the future of medicine, right?
Yeah.
But where do we go from here? What's next? What are the researchers focusing on now?
One of the most promising areas is what we call multimodal analysis. Remember how we talked about each imaging method having its own, pluses and minuses? Well, imagine combining information from all of those different scans, mammograms, ultrasounds, MRIs, CT scans all together.
So it's like instead of just one piece of the puzzle, you're getting the whole picture.
Yeah, like a much more complete view.
But how would that even work? Would doctors have to look at all those images separately?
That's where AI comes in. It can help us integrate all of that data, create this really rich, detailed understanding of the tumor, its size, where it is, its characteristics, even how it's behaving. It's like having a whole team of specialists working together, each one bringing their own expertise to the table.
Okay, so instead of relying on just one type of scan, you're getting this like super detailed, multidimensional view.
Exactly.
But that sounds incredibly complex. Like, how could doctors even begin to process all that information?
That's kind of the point, though, right? That's where AI excels. It can go through massive amounts of data, spot those subtle patterns that we might miss. It can point out potential red flags, track changes over time, even predict how the tumor might behave in the future.
Wow, that's some next level stuff. But we focused a lot on diagnosis. What about treatment? Can multimodal analysis help personalize treatment plans too?
Definitely. We're talking about taking all that imaging data,
Mhm.
combining it with genetic information, lifestyle factors, even a patient's own
Yeah.
preferences to create a truly individualized treatment plan.
It's like custom tailored medicine, basically.
Yeah, precisely. Imagine being able to predict which therapies are going to work best for a specific patient based on their unique tumor and their overall health.
That's like the holy grail of medicine. But with all this amazing potential, there must be some roadblocks. What are the biggest challenges holding us back?
One of the big ones is data access. AI algorithms need a ton of data to learn effectively, and in healthcare, well, that data is often scattered all over the place, different systems, different hospitals. Getting all that data together in a way that protects patient privacy and keeps everything secure, that's a huge challenge.
Right, so it's not just about developing the AI, it's about building the infrastructure to support it.
Exactly. And then there's the human element. Doctors and patients need to be comfortable using these new tools. Doctors need training on how to interpret the AI's results, how to explain it to their patients, how to make it part of their decision-making process.
It's like, yeah, we can develop all this amazing tech, but if people don't know how to use it, it's not going to do much good.
Exactly. And patients need to be part of this too. They need to understand how AI is being used, what the potential benefits and risks are, how it might change their care.
So it's about empowering everyone involved, right? Making sure everyone's on the same page.
Absolutely. Informed decisions all around.
Okay, well, we've covered a lot of ground here, from the nuts and bolts of how AI works to the really mind-blowing possibilities. Any final thoughts before we wrap things up?
I think the key is to approach AI with a sense of both excitement and, well, a healthy dose of caution. AI has the potential to completely transform healthcare. We could detect diseases earlier, personalize treatments, and ultimately save more lives. But we have to be mindful of the risks, the ethical considerations. We have to make sure that AI is being used responsibly in a way that benefits everyone.
Right, so it's not just about the technology itself, it's about how we use it.
Exactly. It's a powerful tool, but it's up to us to make sure it's used for good.
Well said. So, to everyone listening, stay curious, stay informed, and most importantly, stay engaged in this conversation. The future of healthcare is being shaped right now, and your voice matters. Thanks for joining us on the deep dive.